Hello, and welcome back to our introduction to the C programming language. In this session, we'll be going over compiler directives, the C preprocessor, and getting a very brief look at the general structure of a C program. A quick recap from last time, we went over the design goals of C, we went over the legacy of C, and how its operating system independence works. In this session, we'll be going over use of typedef, the preprocessor and compile time directives, and again a very brief overview of how a C program looks. So the C preprocessor and compile time directives. If you remember the pipeline from last time between the programmer and a finished program, the C preprocessor is a step between the text editor and the compiler. They're generally lumped together because the preprocessor is useless without the compiler. The preprocessor modifies source code files before they get compiled. It can be used to do things like only compile certain code, like for example, if you wanted to have multi-platform code, could have certain code get compiled for Linux, certain code get used for Windows, and certain code get used for other platforms while still sharing the rest of the code. It can copy-paste whole files into your source code. That's how you essentially add libraries to your source code, more or less. You can define constants and macros that can be used to inject extra code that can be a little time-consuming to type yourself or confusing to type yourself. You can give specific instructions to the compiler on a file-by-file basis. This is used to, for example, suppress certain warnings or errors from the compiler. Well, not errors, but suppress certain warnings, or give specific instructions on what to do in certain situations. And you can get certain metadata about a program, like what file a certain thing is called in, or what, or the exact date and time that a certain thing is run for logging purposes. These are not all of the preprocessor directives, but these are a lot of them. Include, as we mentioned earlier, can be used to copy and paste entire files into your source code. Define and undef can be used to define macros and constants, or remove those definitions if you need to use them for something else or just need them to go away. If-def, if-ndef, end-if, and else, which are not those two are not listed here, are used for conditional compiling. As mentioned earlier, you can break code apart in some ways to make it so that it only compiles in certain ways under certain conditions. Error can be used to spit out custom compiler errors. File, line, date, type, and timestamp are little bits of metadata that the preprocessor can inject the code to grab whenever you need them. For example, if you are logging errors, you could get the file and line that the error occurred on. You can grab the down to the second or even less than a second time that something is run if you're trying to log just the activity of a long running program. Among other things, there are a lot of uses for these. Pragma is used to deliver those very specific instructions to the compiler on a file-by-file basis. The pound and double pound macro operators are interesting, but they're very seldom used. And in the interest of time, I leave you to investigate these on your own. So, typedef. Typedef is used to allow you to alias type names. In the example given here, we have typedef. We have the name of a type, like for example, unsigned char, and then we have the name we want to refer to this type as, in this case, byte in all caps. You can use this to rename types. You can use this to name new types using structs, which we'll go over later in the course. And in this circumstance, it's just used to give unsigned char a more descriptive name for the purposes we'd be using it for. In this case, it's a byte because unsigned characters are just 1 byte in size. By convention, you usually want these to be all capital letters, but they're user-defined and certain style guides can say you don't have to, and some people just may consider as aesthetically displeasing. So you can 100% use a lowercase name. The only caveat here is your new name cannot be the name of any other type. This is a quick program that we can go over. You don't really need to worry about what this code does. It's more a demonstration of what a C program in general looks like. So we have a couple of preprocessor directives up here. The definition of main, which we'll go over shortly. Some variable declarations, a little bit of executable code, and the return statement. In this sample, it converts a given number of miles to the equivalent. In a sample run, we enter the distance, we enter 10, and it outputs 16.090000 kilometers. We can see the elements of the language that are used in this program, in this admittedly a little bit messy slide here. So we've got preprocessor directives, standard header file, comments are marked by these /*/ blocks. You can see they can span multiple lines. There's a handful of words that are reserved by the C language, like int, void, and double. There's identifiers for library functions, printf and scanf. Special symbols used by the C language, so the equal sign and the asterisk here. Some punctuation in the form of commas and semicolons at the end of every line. That's something you'll get pretty used to. You'll find yourself texting a friend and ending something with a semicolon instead of a period. Happens to all of us. And there's more reserved words and special symbols. It's just generally what a C program looks like. The highlight of that whole ordeal is the main function. Main is what's called an entry point. The compiler looks for a function with a very particular name, particular kinds of arguments it takes, and particular return type, and says, okay, when I finish compiling and linking this, when we run the program, it's going to start from this entry point. It'll start from main. And so everything in your program all revolves around main. There are a handful of reserved words or keywords in the C language. These words have very particular meanings in the syntax of C, and they cannot be used as identifiers. Examples of this are int, void, double, return. Main is not a keyword, but it does have special properties in the context of being used as an entry point, so it can kind of be considered half a keyword. Standard identifiers. Identifiers all follow the same rules, but the names of functions and variables and constants in the standard libraries are generally considered sacred. You don't want to collide with them if you can avoid it. Examples here include printf and scanf, we saw earlier. You can redefine them, but it's generally to be avoided. Your identifiers are anything you name. These names represent locations in memory, be that where a piece of data is stored or where a particular subroutine begins. The names you give them have to follow certain rules. They can only have numbers, letters, and underscores. They can't start with a number. They cannot be a keyword, and you, again, generally do not want them to collide with identifiers in the standard libraries. Very important to remember that C is case sensitive. So if you capitalize a variable name once, you have to capitalize it everywhere. And same goes if you put a capital in the middle of it. You have to put that capital in the same place every time. Here are a handful of valid and invalid identifiers, so it's easier to go over the invalid ones and say why they're wrong. So we have one letter, starts with a number, that's not allowed. Double, that's a keyword, not allowed. 2 times 4, the caps are fine, the star is not fine, the star is reserved. Cost per foot, dashes are not allowed, and Joe's, the single quote, is not allowed. Other than examples like this, you've got good examples over here, and there are a whole lot of different naming conventions that programmers will fight until the end of time over which one is best. Pick one you like and stick with it. As far as variables goes, variables are names for memory cells that data is stored in. This can be a little rough if you don't have a solid model of how memory works in your mind. So it's easier to think of them as just names given to values. In this example, we have miles and kilometers, KMS, that are both of the type double. So the general format is type of the variable, name of the variable, semicolon. We also have an alternative form right here. So type of the variable, name of the variable, comma, name of another variable. You can declare multiple ones on the same line. Assignment is something we did once in that other program, and you can see the line we did it on right here. Assignment is very, very important. What it does is it takes the value on the right, so whatever this ends up resolving to, and it puts it into the value on the left, into the name on the left, more or less. So in this case, what we do is we have a given number of miles and a conversion constant. We multiply them together, and we store the result of all of this in KMS. There are particular rules governing what you can do with the assignment operator that we will go more in depth in later. In summary, we went over a few key parts of the C language. We went over the C preprocessor, got a quick look at type def, and we got a general idea of what a C program looks like. Next time, we'll go over data types, constants, strings, character pointers, storage classes, scope structure, how scopes hide data, and data initialization. As always, on the website, there are live sessions for software engineering and C and C++ programming if you need those. And yeah, thank you for joining us.